All right, so now we're going to take matter, which is anything that has mass and occupies space, and we're going to subcategorize it. So matter can be split into two different categories, one being a pure substance, the other being a mixture. So we can take these two categories and break them down even further. We can take the pure substances and break them down into elements and compounds. Now I would remember these definitions of elements and compounds. You will see them again. So a pure substance can either be an element, no simpler form by a chemical or physical means, or a compound. And when I'm talking about compounds, a compound is two or more different elements bound together. So for instance, water would be a compound because it has hydrogen and oxygen in it. So those two or more different elements combined. Looking at mixtures and breaking that down further, we have homogeneous and heterogeneous. So homogeneous mixture, this would have uniform composition. Okay, so to figure out if something's homogeneous, a good way to do that is if you took two samples of the same mixture and both samples were identical in composition, they had the same percent of every compound present in them, then it would be homogeneous. For heterogeneous, they're not uniform. So if you took two samples and the samples were widely different, it would be heterogeneous. So an example I like to use with heterogeneous is vegetable soup, because vegetable soup has so many different vegetables, noodles, lots of things in it. So say you're eating vegetable soup. No two spoonfuls are ever going to be exactly the same unless you're working really hard to get a uniform composition on each spoonful. One spoonful might have a carrot and a pea. The other spoonful might have a piece of potato and a noodle. Okay, so it's heterogeneous because no two samples are the same. So let's apply this. We're going to identify the following materials as a pure substance or as a mixture. So looking at the first example, hydrogen gas. So hydrogen gas is represented as H2. So let's go back. Looking at the previous slide, what would that be classified as? Would it be a pure substance or a mixture? So it's definitely going to be a pure substance because it's not two or more compounds or elements combined. It's just one. So the pure substances can then be broken down further into either element or compound. So in this case, we need to figure out whether H2 is an element or compound. And it's actually an element. So it doesn't matter that there are two hydrogens present. There could be 10 hydrogens present for all it matters. What matters is it's just one type of element. In order for it to be classified a compound, it needs to be two or more different atoms or elements combined. And we don't have two or more different atoms or elements. We have two of the same element. So that's why hydrogen gas would be an element pure substance. Now let's look at a soft drink. So what do you think a soft drink would be, a pure substance or a mixture? Well, it's actually going to be a mixture because soft drinks have carbonation, so we know it has CO2 in it. Soft drinks also have a syrup of some sort and water and probably a whole bunch of other things we shouldn't be consuming. So it's definitely a mixture. So now we need to figure out if it's homogeneous or if it's heterogeneous. So think about a soft drink. If you took two samples of it, would they be the same? Same composition? And for the most part, they would. So another way of looking at that is homogeneous mixtures, they won't have any visible particles in them. So you won't see any solid particles floating around. And with soft drinks, hopefully, you don't see any solid particles floating around. So a soft drink would be considered a homogeneous mixture. Next is a saline solution. So if you don't know what that is, a saline solution is basically a salt water mixture. And if you ever buy saline solutions over the counter, you'll notice that they have what percent of salt is in them. So notice I said it's salt and water. So I kind of gave it away. It's not a pure substance. It's going to be a mixture because it has salt in it and water in it. So now we need to figure out whether it's homogeneous or heterogeneous. And since when you buy those over-the-counter saline solutions, it tells you the percent, that means each drop is going to be the same composition. So if each drop is the same composition, then it's going to be a homogeneous mixture. Next, gelatin with cut up strawberries. So we're talking Jell-O here. So Jell-O itself is probably a homogeneous mixture. If you've ever made Jell-O before, you heat up hot water, you pour this powder in it, and you stir it until there's no powder left, until it's a uniform mixture. So Jell-O by itself would be homogeneous. Each bite of Jell-O would have the same composition. But since we're adding up the cut strawberries to it, it now changes it into heterogeneous because some pieces of that gelatin might have more strawberries than other pieces. So there's undissolved strawberries, undissolved particles in the solution now, making it heterogeneous. Last but not least, pure sugar. So the pure should be your hint. So it is a pure substance, and in this case it's going to be a compound, because if you see the chemical formula for sugar, it has carbon, hydrogens, and oxygens in it. So it has more than one element, classifying it as a compound. And that is all for chapter 1. So your test will be coming up in just a few days. So start studying and let me know if you have any questions.